Okay, everybody, we're back on this MFP project. This is part 3 of the MFP project. In part 2, I had gotten a couple of questions in my comments. I guess I didn't do a good enough job explaining a couple of things. So I'm going to take the time to do this a little bit now. So this is not the most updated way that it is, but pretty close, okay? As far as I haven't redrawn the pictures. So one of the questions that I was asked by a couple of folks was, am I going to fuse this MFP where the mains come in? And the answer is no. That's not the intention. And the reason it's not the intention is because, as I mentioned previously, I'm going to be building the electronic circuit breaker that was provided to me, the plan as far as most of the parts, the schematic for it, which, let me get the schematic out. This was the box that I had received from my viewer Telefunkian, who has his own channel that has a bunch of parts, circuit board, and all these parts, as well as a couple of parts that I bought on my own in order to complete the project. And in this box are the plans and the schematic for the electronic circuit breaker, which is this, if you guys can see that. I'm not sure if you can see this. But in the electronic circuit breaker, you insert your power in from your AC line voltage, or whatever portion of the AC that you're planning on feeding into the electronic circuit breaker, and depending upon the amount of load that is placed on it, it will shut off. It'll kill the current. So basically, you have your AC in, and then at the end you have your out, right? So you got your AC in, and then you got your load out, and that's shown over here, right? So here's our load out, which is going to be the variac. And so basically this section here, this is a switch, and that's what I've referred to it in my drawing a couple of times now. One of the switches here, the cycle switch. The cycle time switch, I've referred to it a couple of times here now. Alright, that's what I'm talking about, is this particular switch right here that I can set that determines between 2 cycles to 32 cycles. And when we're talking cycles here, we're talking about how quickly this switch is going to, or this whole entire circuit breaker is going to trip. It's running through a relay, right? And the relay is what's powering the load. So depending upon what this circuit sees as far as the load on it, if you go on to Glasslinger's YouTube channel and look up his electronic circuit breaker, or if you go to Telefunkian, his webpage, and look up electronic circuit breaker, they do a really good job of explaining this, and I'm not going to go through that. All I'm trying to tell you is I'm building this into this entire unit, and what should occur then is when I power this MFP up, my line cord, my AC line cord that's going to power up this MFP is going to be plugging into my isolation transformer, right? So the entire thing will be going through an isolation transformer to start with, but the end of the cord that would connect to the MFP will be connecting to the input on the circuit breaker, okay? So everything that is powered by the AC on this MFP will be going through the circuit breaker. I hope that makes sense. So by going through the circuit breaker, it defeats the purpose of needing to have a fuse, because if the current load gets to such that it would blow a fuse, it'll happen much quicker with the circuit breaker. So when it trips, I can reset it. There's no fuse to blow. The other question that I had is, am I planning on keeping batteries powering my component tester, my DMM, the signal tracer? And the answer is no, I'm not. Okay, I got the aluminum bracket made to mount the dummy load resistors on. I'm just going to not worry about this hole here on the one. Either that or I might go ahead and put a screw on it anyway. I made the bracket, I drilled and tapped it for 632 screws. I had a bunch of 632 screws, so I figure I'll put those on there. Let me get that done, we'll come back. Okay, so I got the transformer mounted in there. Obviously, when I get ready to put the filter box back there, I'll take it out. Got my resistors for the dummy load all mounted on the aluminum bracket. I changed my screws to a stainless screw since they're going into aluminum. I'm going to join my these two in series here. I'll run these wires and go from there. Okay, here's what I got. So I decided to use this post as my common negative for everything. It's long enough, I figure I can stick a few more terminals underneath there and use it for my common negative in the whole thing. So as we look at this right now, I've got these 2/8 connected in series. This will be where my wire from my switch will go right here, back to common ground. This one's the 4 ohm, that's where it'll go from the switch, and that's the 8 ohm, that's where it'll go from the switch. I've got a ton of wire down here. That's all from those switches. So I can basically mount this wherever I want to mount it. I'm probably going to go with something like this, somewhere in some vicinity. I just don't know yet exactly where. I'm kind of making components now, and then I'll start joining them together once I get the wiring figured out how is the best to run it. But for right now, that's that. Okay, so one of the things that I've gotten questioned on after my last video that I put up on this MFP was, I going to keep the component tester and the DMM as on battery, or was I going to set it up so that they could run on voltage from the unit when it's turned on? Well, the answer is no, I'm not going to keep the batteries. They are on there temporarily so I could make sure everything worked. But the plan is I'm going to be adding a 12 volt transformer, which I have this one here. It's a Wart transformer. This is actually a 12 volt DC transformer. It's good to 1.5 amps. If you can see that, I'm not sure how the light's hitting it. But this is what I'm going to use, and I have created, using my 3D printer, a DC voltage control board. Now, the various voltages I'm planning on having, if we go back and look at the way I've got this set up, was I have it set up that I was going to have 3.3 volt, 6 volt, 9 volt, and 12 volt. Right now, I've got 5 DC regulators, which these are good to 5 amps. Each one of these are good to 5 amps. I haven't put my heat sinks on them yet, but I will. So I will be feeding each of these off of the 12 volt power supply, and then I will be having the 3.3 volt, the 6 volt, the 9 volt, and 12 volt. Each one of these will be adjusted to it. The top one is going to be set up for the DMM, which takes 3 volts, and the component tester takes 4 volts. And I found that if I use the top one and set it to 4 volts, I can also run a 2.2 meg, I think it is, a 2.2 meg resistor. I have a 2 watt 2.2 meg resistor that I can put in there, and it knocks it down to 3.1 volts. So I think the 3.1 volts will be perfect for the DMM, and have the 4 volts on that, and that way I can get all of my voltages using this control panel. Now, since the time I built that control panel, I decided I want to add one variable voltage, for the instances where these voltages won't work. And so what I'll do is when I build the top portion of this that goes back, I'm going to make another window that'll hold a 6th one of these DC voltage regulators. So, and then I'll put it up at the top. I'm going to go ahead and put a socket down here with this stuff. That'll be the variable one. And that way I'll have these dedicated voltages, and then I'll have the variable one. So that's what we got right now. I also created a bracket to screw this to the base. This has a slight taper to it, so I made my bracket with a slight taper for it. It'll go like that, and then that's going to screw down, and I will solder wires onto these and heat shrink them and run them over, and that'll come off of the electronic circuit breaker. So I wanted to answer that question that was asked a couple different times by a couple different of my viewers, if I was going to keep the batteries or eliminate them. So the answer is I'm eliminating the batteries. So I'm getting ready to wire up this voltage regulator board, but before I do that, I wanted to introduce you to my granddaughter. Now, you guys have probably noticed that I've been a little slow in getting this video out from the past one I had. Well, that's because my daughter and son-in-law and granddaughter came to visit us, and they've been up here for a week, and I wasn't working on anything while they were here. And so they have left me with my granddaughter, Sophie, and let me introduce you to her. Say hi, Sophie.
Hi.
So that's Sophie. We've got her now for another 2 weeks, and then we'll be taking her back to North Carolina, but she's with us right now. And I want to show you something else. So I know this is away from our normal video here, but let's go into the other portion of the workshop. I want to show you something that I purchased recently. I fell into. I don't usually get good deals, but I did get some good deals. So I had an ad for some radio tubes, 9 tubes for $2, and I bought them. Well, the guy's like, well, did you see my ad for my radio? And I said, no. So I looked. So down here at the bottom is a Philco 49, I want to say it's a 619, 618, that I got for $5. And so, I don't know if you can see this, but it's a combination, no, you're not going to be able to see it, but it's a combination turntable. That's a turntable if you open it up. And so I got that for $5. So then we started talking, he started throwing all these other radios in. So I got the Sony, I got this Motorola, got that one, I got that one, Panasonic. Granted, these aren't all old ones, but you know, I got the Zenith. This is a combination 8-track tape player, AM FM. The 8-track goes on the side here. I got that one, little GE. I got that one, this Airline, Montgomery Ward Airline, and I got this Portapal Minerva. So I got all those, all what you see here, plus 2 vintage fans, a 1960 Kenmore and an early 60s Zero that I have already restored, both of them, and they both turned out really nice. But anyway, I got all this for $75, everything you see here. Then I brought it all down in my basement. So while I was doing that, oh, and these here too, I forgot these 2 radios right here. Got this Sony here, and I got this DC power supply, 13.8 volt. I don't know if it works or not. So I got all that for $75. Now, while I'm down here, I'm still showing you, that's the first. I've got this empty cabinet. I got that for free a couple years ago, and I've never used anything with it. And I've got this big Philco here, which is huge, that I got a couple years ago. These have been out in my garage, and I decided to finally get them down in the basement. So, since I had all these radios that I just bought, I decided to get everything down in the basement. So, that's that. But I want to show you that. I don't usually lock into deals like that. So I got the 9 tubes, of which I've tested, by the way. 5 of them were good, 4 were bad. But I got some 80s, I got a 41, I got a 43, and another one I can't think of. But they were good. So, anyhow, it was pretty cool. Wanted to show you that. So, Sophie, what are you doing? See you sitting up my bench there.
Yeah, I was just looking through this cool magnifying glass.
Yeah?
That's very big.
Nice.
Yeah.
Makes things big, huh?
Yeah, I noticed it can help work with small gadgets, so that way you can see what you're doing.
Yep,
if
exactly.
it's very small.
Yep, that's exactly right.
Like perhaps if you lost a small nut, or if you were working with a small nut, you needed to be able to see it, so you would go up under here and use it.
That's
like
right.
That.
Then that's what I use it for.
Yeah. Great.
Okay, so Sophie and
Busy BB.
Busy BB have helped me adjust the regulator board. So the one on top is 4.0, which will also get the 2.2 meg. That'll drop it down to 3.1, and that'll control the DMM and the component tester. And then we got one that's 12 volts, we got one that's 9 volts, we got one that's 6 volts, and we got one that's 3.3 volts. And those will go to the dedicated jacks by little BB's feet right here. So thank you, Busy BB.
You're welcome.
And thank you, Sophie.
You're welcome.
And there we go. There's our board.
Yeah, great causes come with great mechanics.
There you go. Okay, so here's where we are currently. I've got all my little switch panels made. This is the AC-DC switch with the DC out. This is the AC out, along with the AC out there. This is the fixed and variable DC out. This one here is going to be a variable. I'm going to add on the top over there. And then we got 3.3, 5, 9, 12 in common, and an on-off switch for those. This will be for the signal chaser, on-off indicator light, and the BNC jack. And this is the signal tracer, on-off, out. I will also be putting the frequency counter out right here. I haven't got that in there yet, but I will. But now what I need to do is get this all trimmed out for all of this and get these screwed in place. So that's where we're at.